So hopefully you guys can see the properties that you're going to apply. Like one way of doing this, or one thing you might be thinking is, hey, that log base 10 and that log base 10, I want to get rid of it. I'm going to raise both sides of the equation to become powers of base 10 to eliminate it. But the problem is you have a stinking fraction that you're multiplying in front of this logarithm. So if you did put a base 10 right here, it won't cancel because of this number that you're multiplying by the log. So if you know the property, the exponent property, you know that you could take this multiplication of 3/2 and move it up here to become the power 3/2 of base 4. Are you with me? So what we have now is common log, all right, common log base 10 of u equals log base 10 of 4 to the 3/2 power. Now, 3/2, 4 to the 3/2 power, you could actually do that on a calculator if you wanted to. But one way of doing it is recognizing the past lesson, maybe of a month or so ago, power over root. So you could do the 4 to the 3rd power and then do the square root of it, or you could do the square root of 4 and then do the 3rd power. Or you could type it into your calculator. But if you do power over root, well, what is the square root of 4? It's 2. And what's 2 to the 3rd power? It's 8. So what you really have here is an 8. So you have log base 10 of 8 equals log base 10 of u, okay? And now that you have the simple log base 10 on both sides, that's where you raise both sides to become powers of base 10. That way it eliminates, and you end up with u equals 8. And of course, double check, take a quick second, make sure that if you plug in the 8, you don't end up with 0 or a negative inside a logarithm, because that would be an extraneous solution. But right here, 8's cool because 8 is positive. On this question, you might be thinking, you know what? I'm going to raise it to become the power of base 6 and power of base 6. But don't do that because that's wrong. Okay, that's wrong. Because, this will cancel out, but this does, actually, it doesn't cancel out because this whole thing is the power of 6. So you have to have a single log, like over here it will, but you have to have a single log on both sides to be able to cancel them out. And the problem is you have 2 log base 6s on this side. And if you have 2 of them and you want one of them, that's where you should be like, oh, wait a minute. The product property allows me to go backwards to condense. That if I have log base 6 of something plus the same base 6 of something else, I could condense these and put one single log base 6. And what happens with the x and the 9 on the product property? You multiply them together. So you're going to have x times 9, and that's really a 9x. So you really have log base 6 of 9x. And now it's equal to log base 6 of 54. And now that you have a single log base 6 on the left side and a single log base 6 on the right side, you could raise them to become powers of that base 6. That way they eliminate. And what comes down is the 9x equaling 54. Then you simply divide by 9, and you get your answer, x equals 6. And just take a quick moment and make sure that if you plug it in into the x, you don't end up with the log of a negative or log of 0. And it doesn't, so you're good. That's your answer, x equals 6. Any questions? No. Excellent. Moving on, let's copy down this guy. Okay, so when you look at an equation, you got to think, I want a single log on each side. That way I could raise both sides to become the power of base 9, right? But I have 2 different types, or 2 logs, the same base 9. So I want to condense this with a certain property. Are we going to use the product property? No. Are we going to use the quotient property? Yes. Why quotient? Because of that minus sign. Remember, the quotient becomes subtraction if you're expanding, or the subtraction becomes division if you're condensing. So because we have the identical log base 9 and identical log base 9, we're going to put it together as a single log base 9. Log base 9 of what? Log base 9 of a fraction. That fraction, the first term, this guy goes up on top, and that'll be 3u plus 14. and the 5 goes on the bottom. First one goes on top, the second one goes on the bottom. Both logs, the same base 9, condensed to a single log base 9. So now you have log base 9 of that fraction equaling log base 9 of 2u. And now that you have a single log base 9 on the left side, a single log base 9 on the right side, now you could raise both sides to become powers of base 9. And of course, that eliminates. So now you have a simple equation, 3u plus 14 over 5 equals 2u. You want to solve? Let's get u by itself on one side. The problem is u is on both sides, and you have u inside the numerator of a fraction. We don't want that. So let's get rid of that fraction first by multiplying by 5. Cancels out. What you do to one side, do to the other. You're going to end up with 3u plus 14 equals 10u. And we almost have u by itself. Let's get u by itself on one side. Let's move that 3u to the other side. Subtract 3u, subtract 3u. You're going to have 14 equals 7u. And for your final step, you're going to get rid of that multiplication of 7 by dividing by 7, dividing by 7, and you will get 2 equals u, or u equals 2. Now, take a brief moment and make sure that that 2, when you plug it in, doesn't give you a negative on the inside or a 0. So 3 times 2 is 6. 6 plus 14, that's good. It's positive. If you put in the 2 right there, 2 times 2 is 4. That's good. It's positive. As long as it's not 0 or negative, it is a valid answer. If you plug it in, like let's say this would have been let's say this would have been a minus 6, and you plug in the 2. 6 minus 6 is 0. You can't do log base 9 of 0. There is no such answer. So there would be no solution if that were the case. Go ahead and jot this one down. It gets more fun. So yes, you don't want 2 separate logs. You want to condense them. But the thing is, you can't condense them if you have a negative in the front and if you have a 1/3 in the front. So you're not going to do the product property yet. You're going to do the power property first to get rid of the 1/3 and to get rid of this minus sign. Okay. Now this minus sign is like a -1. So imagine that you got a -1 right here, and you're going to take that -1 and you're going to raise it to become the power of base 16. So you're going to have 16 to the -1 power. Okay. And we should all know that 16 to the -1, that means that you take that 16 and move it underneath on a fraction, right? So we're going to end up with log base 3, but instead of 16 to the -1, I'm going to write 1 over 16 to the +1, which is just 1 over 16. Did that make sense? Again, this is a -1. You're going to use the power property to move it up to become a power. And then 16 to the -1, you could actually do that. It becomes 1/16. And we're going to do the same thing. We're going to use the power property with this 1/3 multiplied by log base 3 is 64. I'm going to take that 1/3 and I'm going to move it up to become the power of 64. So 64 to the 1/3 power is what I really have. Okay, so I have the plus sign. I have log base 3 of 64 to the 1/3 power. The question is, what is 64 to the 1/3 power? The 1/3 power is the same thing as a cube root, right? So you really have the cube root is 64, which is 4, okay? So instead of 64 to the 1/3, I'm going to rewrite it as 4. Or you could type in 64 to the 1/3 power on your calculator, and it'll give you the answer 4, okay? So far, all I've done is applied the power property. The numbers that are being multiplied out in the front, I rose them up to become powers of that base, and then I did some math, and I did some math, and I got this, right? And now I could use the product property that if you have the same type of log plus the same type of log, you could condense them to be one single log as long as you multiply those two values. So what I really have on my right side of my equal sign is log base 3 of 1/16 times 4 is 4/16, which reduces down to 1/4. So I really have log base 3 of 1/4. If you did this on the calculator, 1/16 times 4, it will reduce down to 1/4. It'll give you 1/4. Now, on the left side of the equal sign, I still have that original log base 3 of y. And now that we have this new equation, this simplified equation, I made it simple with the properties, with the power property and the product property. We could now get rid of these log base 3s by raising both sides to become the powers of base 3. That way eliminates, and you end up with y equaling 1/4. Okay? Now, take a brief moment and make sure that if you plug it in, when you plug it in, you're plugging it into y, and it's not negative, so we're good. Moving on. Try that one right there. Copy that one down, please. So, again, you got to get comfortable with all the properties. They're on the wall. You should have them in your notes. If you see a plus sign between two logarithms, you know you could apply the product property. If you see a minus sign between two of the same logarithms, you know you could apply the quotient property, right? And if you see a number being multiplied out in front, that's the first thing that you have to do, right? You could move it up to become the power. Oh, wait a minute. Ooh. Okay, so in math, there's many roads to the same place. So I could move this 5 to become the power of base 2. But then again, when you have log base 2 of 2 to the 5th, the log base 2 of 2 cancels out and the 5 comes down. Or you could just leave it out here and say 5 times log base 2 of 2. We know that that's really a 1. So it'd be 5 times 1. You'd get 5 either way. Since we are practicing the properties, I am going to move it up. Put a 5 right there. I will have log base 2 of 2 to the 5th power. And we all know that log base 2 of 2 cancels out. So you end up with just a nice, beautiful 5 right there. So this whole first part of the right-hand side of the equation becomes a nice, beautiful 5. Not only that, wow, this is ridiculous. This is easier than I thought. This log base 2 of 8, you could actually do that, right? 2 to what power gives you 8? 3. So you really have the minus sign, and then you have this, which equals 3. So you really have 5 take away 3, which is 2. So the equal sign comes down. You have the answer 2 on the right side. On the left side, you have log base 2 of d. Okay, now what's the problem here? You don't want log base 2 of d. You want d by itself. You don't want that log base 2 of d. So get rid of the log base 2 by raising it to become the power of base 2. As long as what you do to one side, you do to the other side, raise it to become the power of base 2. So yes, 2 to the log base 2 cancels out. The d comes down, and 2 squared is 4. And there's your answer. But double check it. Make sure that when you plug it in, you don't end up with the negative on the inside, which you don't, or 0. Could this have been done differently? Yes, it could have. You end up with the same answer anyway. Copy that one down. That one's going to be a good one. I don't know why the worksheet actually put base 10. If it just said log with that stuff, you automatically assume that's a common log base 10, but they wrote it with base 10. Anyway, again, you want to get very familiar with the properties. If you ever have like a number that's out here being multiplied, like a 5 out here, you raise it to become the power, you condense it with the power property. If you ever have addition of the two same type of logs, you could condense them with the product property. That's what we're going to apply right now. If there were a minus sign, you'd condense it with the quotient property. But with the plus sign, it's the product property. So you're going to, this log base 10 and that log base 10, you're going to write them together as a single log base 10. As long as you multiply this guy times this guy. So you really have b plus 3 that you need to multiply times the b, okay? And that involves distributive property. B times b is b squared, and b times 3 is 3b. So you really have b squared plus 3b inside parentheses with the log base 10 in front of it. So the whole left side, log base 10 of this junk plus log base 10 of that, becomes log base 10 of this. You condensed it, you now have one log base 10 on the left side. On the right side, you also have log base 10 of 4. So of course, you're going to raise both sides of this equation to become powers of base 10. And you're going to end up with b squared plus 3b equals 4. And we need to solve. And you need to recognize that it is a quadratic. There's a b squared and a regular b. And for quadratic equations, you solve them first by setting them equal to 0. So subtract 4, subtract 4. We're going to have b squared plus 3b minus 4 equals 0. And then from there, you could use the quadratic formula. You could factor it, split it, and solve it. Shoot, you could even graph it on Desmos and see where it crosses the x-axis, and that would give you the answers as well. Okay, so I could see that it's factorable. Parenthesis, b, b. What times what is the c value, -4, that if you add together is a b value, +3. Make a list. It's either -1 times 4 or -2 times 2. Obviously, it's the first pair of numbers. So that's a -1 and a +4. And now it's factored, and now you could use zero product property to split it and solve. B minus 1 times b plus 4 equals 0. That means that b minus 1 could equal 0, and also b plus 4 could also equal 0. So your two answers are b equals +1 and b equals -4. Maybe. Why do I say maybe? Because when we check the original, if you end up with a negative inside a logarithm, or if you end up with 0 inside a logarithm, it's impossible, right? So plugging in a 1, that's cool. 1 plus 3 is 4, no problem. Put a 1 right there, no problem. But if you plug in the -4, log base 10 of -4, you can't do the log of a negative number. So that means that this guy over here is extraneous. Do not include that in your answer. If you type in the answer -4, it's going to be marked wrong. It's only the answer 1, okay? Because when you plug in a 1, you get a 4. Plug in a 1, you're good. But if you plug in a -4, you still get a -1. You can't do the log of a negative number. So it's always important to take a couple of seconds to verify your answers, that you don't end up with 0 or negatives inside the logarithm itself. Again, if you wanted to, you could have graphed on Desmos x squared plus 3x minus 4, and you'd see a parabola that crosses at 1 and -4, which provides you the answers, but you still need to double check and make sure that you don't end up with 0 or negatives inside the logarithms, because you can't do that. 19 it is, why not? Once again, think of all the properties. If you had a number out here in the front, you'd make it a power. If you had addition, you would condense it with the product property and make it multiplication. But you have subtraction, so you're going to condense it and make it what? Division. You have log base 8 and log base 8. Let's write it together as one single log base 8. But we're going to have a division problem right here. And of course, you're going to write the first one on top, t plus 10, and the second one on the bottom, t minus 1. That's what we call condensing using the quotient property. And you have the equal sign. And of course, you have that same log base 8, but it's of 12. So now you have log base 8 on both sides. You could raise both sides to become powers of base 8. They eliminate. Base 8 eliminate. What do we have left? We have the fraction t plus 10 over t minus 1 equals 12. Let's get t by itself on one side. The problem is you have a fraction involving t in the denominator. Let's get rid of that fraction. We're going to multiply both sides by t minus 1. We do to one side, do to the other. And all you're doing is canceling. And now you have a regular t plus 10 equals 12t minus 12 when you distribute. Let's get t to one side and the numbers to the other. I'm going to move this minus 12 by adding 12. Adding 12. I'm going to subtract this t. Subtract it from over here. So I'm going to have 22 equals 11t. Almost done. Final step. We're going to get rid of that multiplication of 11. by dividing by 11, and t equals 2. And take a moment and make sure that when you plug in the 2, you don't end up with 0 or a negative. That gives you 12, we're good. Plug in 2, 2 minus 1 is 1, we're good. And that is all. What? You want another one? Okay. We are going to condense the left side with the product property because of the plus sign. So you're going to take this log base 3 and that log base 3 and write it as a single log base 3. But of course, you're going to have to multiply this guy with this guy. So I'm going to write in there the a plus 3 as a binomial times a plus 2 as a binomial. So this is going to require some work. I'm going to zoom in, then I'll zoom out again. We're going to distribute a times a squared. A times 2, 2a. 3 times a, 3a. 3 times 2, 6. Combine 2a plus 3a, you'll get a positive 5a. So you have a squared plus 5a plus 6. That's a quadratic trinomial that belongs inside the log base 3. Are you with me? So the whole left side becomes log base 3 of that quadratic trinomial. And it is equal to this log base 3 of 6. I mean, it's worth thinking about. 3 to a certain power give you 6. No, it doesn't work. Okay, so we're not going to mess with that. But you could have actually done it. Maybe if it were a 9, then it would have become a 2. But can't do it. So let's continue. We want to get rid of the log base 3 on both sides. You're going to raise both sides to become powers of base 3. They eliminate. What's left? A squared plus 5a plus 6 equals 6. You want to solve this thing, set it equal to 0, subtract 6, cancels out. What do we have? We have a squared plus 5a equals 0. Now you still need to solve this thing. You could factor, split, and solve. You could use the quadratic formula. You could even type it in on Desmos as y equals this stuff and see where the parabola crosses the x-axis. I am going to factor, split, and solve. You could pull out the GCF, which is a single a. What would be left on the inside? Well, a times a will get you the a squared, and a times what gets you back to 5a? A times positive 5 gets you back to 5a. It is equal to 0. Now that you have something times something equals 0, the first something could be 0, and also the second something could be 0. And you solve both, but one of them's already solved for you. A equals 0. The other one, subtract 5, a equals negative 5. There's your other answer. But make sure you double check that you don't end up with negatives on the inside of your logarithms. So plugging in 0, actually, if you end up with a 0 inside your logarithm, it's also incorrect. So plugging in 0, you don't end up with 0, so you're good. 0 plus 3 is 3, that's fine. 0 plus 2 is 2, that's fine. Nothing to plug in over here. But when you plug in a negative 5 plus 3 is negative 2. And it's impossible to do the log base anything of a negative number or even of 0. So that means that a equals negative 5 is extraneous. Do not include that in your answer. It's just a equals 0. So on this question, you got to think of all the different properties. Obviously, there's no numbers out here in the front. Like if I had a times 2 out here in the front, I could raise that to become the power of 2. And you would have to distribute if you had the power of 2. But there is no number in the front, so we're not using the power property. There is no plus sign anywhere, so we're not doing the product property. There is a minus sign, so we're going to be doing the quotient property first to condense. So you have this log base 10, which is technically a common log. They didn't even have to write that log base 10. You have that log base 10. We're going to write it as a single log base 10. What we're going to do is use the quotient property, which means we're going to be dividing this guy by this guy. So you're going to have an r plus 4 up on top over an r on the bottom. Maybe I should have kept this in red. So it's log base 10 of that fraction, and it equals log base 10 of this expression over here, the r plus 1. So because you have a single log base 10 on the left side, a single log base 10 on the right side, you could raise both sides to become the powers of base 10, and it'll eliminate, and you'll have a nice r plus 4 over r equaling r plus 1, okay? Now, the problem here is when you try to solve for r, there's r in the denominator of a fraction, and you don't want r in the denominator of a fraction. So you're going to have to multiply both sides by r. So you're going to multiply by r, and that cancels out. But you also have to multiply the other side by r, and I'm talking about the whole thing. You got to multiply it by r. So you're going to distribute, and you're going to have, on the left side, you're going to have an r plus 4. You have the equal sign, but now you're going to have an r squared plus 1r. And we do have a quadratic equation. And whenever you have a quadratic equation, you should set it equal to 0. And then you could try to factor, split, and solve, or you could factor using the quadratic formula, or you might even be able to graph it on Desmos and find the points of intersection. So right here, we're going to subtract r, cancels out. What we now have, let me write it up here, we have 4 equals r squared. 4 equals r squared. And you want to get r by itself. You want to solve for r. So how do you get rid of a square? Square root. So what you do to one side, do to the other. And when you apply a square root in an equation, yes, you get the answer 2, but you have to put a plus or minus in front of your answer. So you really have r equals plus or minus 2. R equals plus or minus 2. That means that you have both r being positive 2 and r being negative 2. But you got to take a moment and make sure that when you plug in, you don't end up with a 0 or a negative number. So plug in the 2, 2 plus 4 is 6, you're good. Plug in the 2, log base 10 of 2, you're good. Plug in the 2, 2 plus 1 is 3, you're good. But when you do the negative 2, right here, it messes it up. Like, it's okay on the first one. Negative 2 plus 4 is positive 2, you're good. But negative 2 right here, log base 10 of negative 2, you cannot do that. And even on the last one, negative 2 right here, that gives you a negative 1. And you cannot do the log of a negative number. You can't even do the log of 0. So what does that mean? That this guy is an extraneous solution. So you're not going to write your answer, r being plus or minus 2. It's not negative 2. Negative 2 is an extra answer that doesn't work. So the only answer is r equals 2. I hope that makes sense. All right. Now, in math, of course, it gets more fun. Let's copy this one down. So as you can see on this question, there's an addition sign between the two log base 8s. So you should be thinking that you're going to apply the product property, because the multiplication becomes addition, or if you're condensing, the addition becomes multiplication. So condensing with the product property, you have log base 8, you have log base 8, you're going to write it a single log base 8, but you need to multiply this guy times this guy, right? So inside your log base 8, you're going to have n minus 3 times n plus 4 before you do anything else. So we're going to zoom in and actually do this n minus 3 times n plus 4. So n times n is n squared. N times 4 is 4n. Negative 3 times n is negative 3n. And negative 3 times 4 is negative 12. And of course, you could combine the 4 with the minus 3, and you will get n squared plus 1n minus 12. And that is inside your log base 8. We've condensed with the product property. Get it? Good. And that's the left side of the equal sign. The right side has a simple, beautiful 1. And we could get rid of now the log base 8. We could get rid of it how? By raising it to become the power of base 8. Base 8 cancels out. We now have n squared plus n minus 12 equals 8 to the 1 is 8. And again, you have a quadratic. And again, to solve a quadratic, you have to set it equal to 0 and then solve, right? So we're going to get rid of the 8, get rid of the 8. What you do to one side, do to the other. You're going to rewrite it. It's n squared plus n minus 16 equals 0. Minus 20. My bad. Minus 20 equals 0. And then from there, if you wanted to, you could go to Desmos and type in y equals x squared plus x minus 20. It'll give you a parabola that opens up, that crosses the x-axis at positive 5 and negative 4. And that gives you your answers, n equals positive 5 and negative 4. But I know that I could factor this pretty easily. I'm going to rewrite it. in factored form, n, thinking what times what is the C value, -20, that if you add together is a B value, +1. You might want to make a list, -1 times 20, -2 times 10, -3 doesn't work, -4 times 5. You start adding those up. This is the pair of number that works that gives you the 1 in the middle. And you don't have to change any signs. So that is a -4 and a +5. Now that it's in factored form and it's equal to 0, now you could split them and solve them each. So you really have n-4 equals 0 and n plus 5 equals 0. So your two answers are n equals +4 and n equals -5. I hope you guys understand that, but you still need to double check and make sure that you don't end up with a negative inside a logarithm or 0 inside a logarithm. So when you plug in that 4, 4 minus 3 is 1, you're good. Plug in the 4, 4 plus 4 is 8, you're good. Plug in the -5, -5 minus 3 is -8. You cannot do log base 8 of -8. Can't do log base anything of any negative number or even of 0. So just with that right there, this guy doesn't work. The only answer is n equals 4. And you're going to have to do this on the next test. So make sure you understand it. Let's do another one. I really like this one because it gets you thinking. It gets you thinking. Now, so some of us are going to see this multiplication of 3 and think, oh, that's the power property, right? That's a power property. I could take this 3 and make it a power right there. So when I first saw this problem, that's what I did. And then I started thinking, well, wait a minute, x squared plus 9 to the third power, that's not going to be fun. That's going to take a lot of work. Even if I use Pascal's triangle, I can get a huge polynomial right there, right? So maybe we shouldn't mess with that, okay? So let's not put that 3 as a power. What we're going to do is look at other paths that may be easier. Well, an equation is all about solving, all about getting x by itself. So I see that there's a single x squared on this entire equation. So I could technically start getting x by itself. What's an easy thing to get rid of on the left side? The -6 for sure. So let's get rid of that -6 by going +6. What you do to one side, do to the other, +6. You're going to have 3 times log base 5 of x squared plus 9 equals 0 plus 6 is 6. Now, I could get rid of this multiplication of 3 by simply dividing the whole side by 3 and dividing the whole side by 3. Then you'll have log base 5 of x squared plus 9 equals 2. So that's great that some of you saw that this 3 would go up here to become a power. That is true, but it gets really ugly if you went that route. You should be able to get to the same answer, but it's a lot easier if you do what we're doing here of getting x by itself by eliminating things. We eliminated the -6 with the +6. We eliminated the multiplication of 3 by dividing by 3. And now we're going to eliminate the log base 5. How? By raising it up to become the power of base 5. And what you do to one side, do to the other side. So log base 5 of 5 cancels out. We now have the x squared plus 9 come down. That's the only thing on the left side. And 5 squared is 25 on the right side. So again, my whole purpose is to get x by itself on one side. What do I do next? I want to get rid of that plus 9 by subtracting 9 and subtracting 9. So my new equation becomes x squared equals 25 minus 9. That's 16. My final step to get rid of that square, you're going to apply a square root. What you do to one side, do to the other. However, when you do apply a square root, yes, you get rid of the square. It's now x equals, but you have to put a plus or minus in front of your answer 4, which means that you have two answers, x equals 4 and x equals -4, okay? Now the question is, will either one of these give us 0 or a negative number inside a logarithm? If you plug in 4, 4 squared is 16. 16 plus 9 is positive. You don't have 0, you don't have a negative, you're good. If you plug in a -4, you also get a positive number because -4 times itself, -4 squared is also positive 16, which gives you a positive value. So both of these are the correct answer, okay? I hope that makes sense. Excellent. Should we do one more? Yes, please. All right, let's do one more. So If you're thinking product property, you can't really apply it, even though there's a plus sign. Remember, product property has log base 6 of something plus log base 6 of something else. Then you could condense it to a single log base 6. But the problem is there is no log base 6 in front of the 1. So, and you can't raise both sides to become power of base 6 because of this extra plus 1 right here. So what we're going to do is move the log base 6s to be on the same side. In other words, I'm going to subtract log base 6 of 2x minus 5. That way, it cancels out. And what I do to one side, I do to the other side. I want to subtract log base 6 of 2x minus 5 over here. Now, of course, you can't really, it's not like a number that you could subtract that number. We can't really do it yet. So what we're going to do is just rewrite what we have. On the left side of the equal sign, we have a positive 1. On the right side of the equal sign, we have the log base 6 of 7x plus 10, and then minus log base 6 of 2x minus 5. You guys see what I'm doing? What am I doing? Yes, quotient property. Yes, I set it up so we could condense with the quotient property. So the log base 6 and the log base 6, you're going to condense it to a single log base 6, and you're going to have a fraction, and the top number is the first term, which is a binomial 7x plus 10, and the bottom number is the second term, which in this case is a binomial 2x minus 5. So what we really have is 1 equals that. Now you want to solve for x, but the problem is x is inside log base 6. You don't want log base 6, so how do you get rid of log base 6? Raise it, put a power of base 6, make it as a power of base 6. What you do to one side, do to the other. So now you have 6 to the 1. What's 6 to the 1? 6. And what about 6 to the log base 6? Nada, cancels out. So the fraction comes down as a regular term now. So that's really 7x plus 10 with the 2x minus 5. And now we want to get rid of the fraction because it has an x in the denominator. So we're going to multiply both sides by this exact binomial, 2x minus 5. That way it eliminates, and what you do to one side, do to the other, multiply by 2x minus 5. And over here, you're going to distribute, and you will get a 12x minus 30 equals 7x plus 10. I know, fun stuff. And then you want to get x by itself on one side. So I'm going to move the 7x to the left. And I want to also move the negative 30. I want to add 30 and move it to the right. So what we're going to end up with is 12 take away 7 is 5x. 5x equals 10 plus 30 is 40. 5x equals 40. Divide by 5, x equals 8. But make sure that when you plug in that x value of 8, you don't end up with 0 or negative, which you don't. 2 times 8, 16. 16 minus 5 is positive. 8 times 7 is 56 plus 10 is positive. That is our answer for number 27. Fun stuff.